Why does a spinning ice skate, their angular velocity, I'm pretty sure they're supposed to say velocity over here, it just didn't show up over here. There is no way that this is grammarly correct. Uh, if not, then yeah, if that's what's supposed to be it, then I don't know. I have no faith on the universe, but I just think it didn't render correctly. That's the only explanation I have for that one. No velocity. Yeah, that doesn't make sense. What's angular? Nothing. Yeah. Literally, if you say angular, that means nothing. Anyways, increase angular velocity, increase as she begins, brings her arm towards her body. So basically, what it's asking is you have this, you have this, you have a human, right? And you're already spinning. If you move it inside, the I omega, I believe, has to equal the same. So there's, momentum, right? There's angular momentum, and angular momentum must stay the same, and I is in play here. So I'm pretty sure that's the reason why. Yeah. And basically, if your moment of inertia is defined by, I believe, mass times r squared for a point mass. So you can imagine if you move it inwards, right? You would be decreasing that. So the angular velocity must go insane to compensate for whatever is happening. So the angular velocity, angular momentum is constant, is the reason why. But that doesn't indicate that's the answer, right? Because that could be just one reason. Her mass moment of inertia is reduced, and that is actually two, because mass moment of inertia is actually just I in the angular space. So that is reduced, making the omega spin out of control. Her radius of gyration is reduced, and I figure what gyration is. That is true. Radius of gyration is r times x, and that's basically d. So in this situation, everything here is correct. Nothing here is wrong, is what I'm trying to put down. Okay, next question. Go down. Okay, link A and B. All right, here we have this question where we're supposed to do a linkage and get BC when the link of AB is horizontal and CD is vertical. So CD is vertical, so C doesn't have a velocity over here. And this is just going to have 0. Nothing to worry about there. Yeah. But VB, on the other hand, definitely has something. Using omega AB is basically multiplied by 5, which is R, equals the VB. VB equals about 50 meters per second. That is clear. Now, the second thing we have to look at is if I can find it ever here. I need to find it first. Is using the relative angular velocities as a cross product. Yeah, here it is. Here it is, the weird angular cross product stuff. So VA equal VB plus omega RA slash B. So in this case, we have VB, which is VB over there. And we're going to do relative RA slash B, right? And R slash AB, if I were to say, why don't we claim this and this? So VB equal VC plus omega BC. And this is it doesn't matter the direction, I believe, so we're good. But preferably we know the direction. And then this is RB over C. Okay. So RB over C is this, which is this R equal because of the 3 and 4. This is a 5 triangle. So we can denote ourselves as 4I plus minus 3J. Over here, VB was 50, so equal VC. VC is 0. So 50 equal omega B times R. Cross, sorry, this is supposed to be cross. That's supposed to say cross, right? Yeah, cross. Cross R, BC. We know that in the graph over here, that if we have something like this, the IC must be over here, because if you do a cross product, it's basically doing a moment, actually, and the only way to get something out of it is with the VB. So that's 50. And with that said, omega BC basically equals R, which is going to be 4 here in this case, equal 50. So 50 divided by 4 is the answer. Let me grab my calculator and do this. 50 divided by 4 is about 12.5. 12.5, and there's only one clockwise, which I must have did the cross product wrong, but it is D. D, sorry. D. And that is true. But I must have done some kind of cross product wrong because it should have got to the negative for that. But anyways, I got the value correctly, and we're gonna keep on doing that stuff here. This one over here, we have 3 meters per second. So we're doing a cross product basically again, and this is basically what we have. And here's 3, and we know this over here is 3. Which was the angle over here? 30, 30, 30, 30 over here. So cosine, no, it's a sine then. So we have 3 sine theta, and we have over here 3 cosine theta over here. We begin with those two. Now, what we can do is basically look at this and say, remember this, VA equal VB plus omega cross R A and B. Here's the thing. This is another way to say moment, but for velocity. So if we look over here, um, yes, we can basically say because the one like, member over here, we can do a omega check, omega, because this is still one member. We don't even have to look at this actually. That's the wrong way of looking at it, actually. The better way to do it, omega R equal V, because this is one body, one linkage. So this must be true. And then we can do V equal omega R. So we can do we can get we already have velocity, so we can do omega equal V over R. And in this case, R is this, because how it works is that we need to find the spacing that is normal for a moment. It's for a cross product that is related to a region. So we'd have to explain it. It's basically like moment, but it's specificer. So we can do 3, because 3, I believe 3 meters per second, divided by R, which is 3 sine 30, equal on 3, 3 sine 30, parentheses, equal about 2. With that 2, we have a very much what we call omega equal 2 in this case. And that can equal to basically the VB, right, divided by 3 cosine 30, basically. And then with that 2 multiplied by 3 cosine 30, parentheses, equals basically something like something similar to 5.19, so D. It is D. With that said, we can do the next one. A motorcycle travels on a horizontal, unbanked circular track of radius r. The coefficient of friction is mu equals 0.3. We'll have to trust 0.3 on that word. If the car's velocity is 10 meters per second, what's the smallest radius it can travel without skidding? Well, basically, this force is from friction, actually. Sorry, the two. So that force of friction is mu over n, and there's no angle, right? Or no applied or static or whatever weird force. So whatever the mass of the thing is, it's going to be the normal force, basically. It's going to be mg then. And just read the question again. Okay. And then the velocity is over here. What's the smallest radius it can travel? So yeah, that probably is it. And all we have to do is Fc equals F friction, because there's going to be an FC because of this velocity. So all we have to do is this fictitious force, figure out what this fictitious force is. You know what? I already know what it is. This over here is R omega square. I don't know. I mean, I could try to look it up in the thing, but I don't need to. I know what it is. The fictitious acceleration is R omega square multiplied by m, and then we can do m equal v squared divided by r equal mu m, which is deleted, g, right? And what we're trying to figure out is smallest radius of turn. Right, right. So we try to figure out R. So we can do R equal B square mu G, basically. So with that said, we can now do on the top, it says what, 10 meters? 10 meters per second square, divided by mu, which is 0.3, multiplied by 9.8, which is basically 34. So it's 34. There we go. B. Yeah. That said, next question. So here we have all the same rules as problem number 4, but the angle is banked by 5 degrees. So all we have to do is do this analysis. And with the summation of fx first, we see the normal over here, and we see a friction force this way. And obviously we know this has to equal mc. MC is r omega squared, which is this way. So it's actually equal to say mvr squared. And that's because it's a fictitious force. Therefore, you don't draw it in the free body diagram. It's above it. So that must equal, so by this logic, I have a normal force, and then this normal force is kind of like, if I do something like this is theta, so this is sine theta, plus if I were to do this one, that is about here, that is theta, that's cosine, so that is mu and cosine theta, and then there's one other force I'm not thinking of. Am I? No, I don't think that's right. I think that's right. And then we do summation of Fy. This is equal to negative mg, right? There's a negative mg in this equation, unlike the other ones that didn't have any force. This one is negative mg, right? With that logic in play, we also need to apply the other forces, which is positive, right? And cosine theta, and then it is plus mu n sine theta. And it's going to, I guess I decided that this direction is positive, positive apparently, which is fine. It's not like it's a big deal. It's not like it's going to cause any problems with the math, hopefully. Assuming it doesn't have any problem with the math. Okay, now we're going to divide these two. Mostly because I don't want to solve for n. Literally, that's the only reason I've been doing this way. Traditionally, the way you do it is with tan or something. But I don't want to do it that way because, yeah. So we're just going to do it this way. Uh, yeah. Actually, this one's minus according to the graph. This is minus direction, right? Yeah. So with that said, this equals 0, by the way, equals 0, right? With that said, all right, we can solve this now because we could do n cosine theta minus mu n sine theta equal mg, and then I could do sine theta plus mu cosine theta divided by cosine theta minus mu sine theta, and then do mv squared divided by r by mg. Cancel this out. Yeah, I did it this way because I feel like I don't want to do the math on the normal. You can do the math on the normal if you want. That's a traditional way. I'm not doing that. So with that said, we have the formula. So v squared divided by rg equals whatever this is. Sine 5 plus whatever mu is, which was 0.3. Cosine 5, cosine 5 plus 0 minus minus 3 sine 5. And let me just grab my calculator and do the math over here. Okay. And then obviously you do some v equals 10. So 10 squared. Oh, let me just do this real quick on the calculator. 0.3 sine 5 parentheses. Okay, I guess like 0.39. Okay, 0.39, 0.39. And you leave g over here, and then 10 squared equal r. Well, I get 25.6. I'm assuming it's C. I get r equal 25.64. I'm assuming it is C. There's multiple ways to solve this one. I just solved it one way. Traditionally, there probably is like 16 different ways to solve that one, actually. That's such a traditional question. 2 kilogram mass swings in a vertical plane at the end of a 2 meters chord where 30 degrees happens. The magnitude of the tangential velocity is 1. Okay. So I'm assuming gravity is having effect here. If not, then I don't know what I'm doing because it clearly is a gravitational question where gravity is going down and looping up, I'm assuming. If not, then okay. Vertical plane, right? Of the end of the two chord. Okay, yeah, we already read that. What is the tension of the chord of that position? So is it a constant swing? Yeah, I think it is. So we can assume that it's something like this. It's not a pendulum also. So we can do something like this, being the force applied. And, huh, depending on how this is, we could generally be seeing something like this. A force over here, which is AC, and then AT, tangential. I only know this because my professor in my when I took 4A told me that if you're going to move that way, you need actually a tangential, there might be a tangential acceleration force over there if you're doing that. Either way, AC is first, right? AC. We begin with that, which is, um, b- isn't this just V squared divided by R, which is basically 1 divided by whatever the chord is 2, so 0.5 is AC. AC equals 0.5. I think that's true. Now we need to do the Fn summation, I think. So let's do it. So let me just do this over here. AC equals 0.5, right? And then we have something like this and this as our force diagram. So summation of Fn normal. So that equals MAN, which equals weight. Let me just look at this. this is an angle over here, which is 30, which means is cosine 30 plus t minus, sorry. All right, that is true, right? Okay. So this is minus mg cosine 30 plus t equal mac. So minus mg cosine 30, so plus mac equal t. All right, we got it. So it's 2 multiplied by 9.8 cosine 30. And let's just do multiply 9.8 parentheses plus 2 multiplied by what is this? 0.5 equal about 17.9, which is about 18. So I'm assuming that is A. With that said, we move on to the next question. All right, we start over here. A 2 kilogram swing in a horizontal plane of a circle of radius 1.5 is held in taut cord. The tension is the cord is 100 newtons. What is the angular momentum of the mass? So angular momentum is H equal R cross MB, or other known as R cross P. MV. Anyways, with that said, we can now solve this. How we're solving it is simple. First of all, we're looking at a circle over here. So this is over here. We have 100 newtons over here. That it will be 100 equals going to be the AC or centrifugal force. So we can just do force C, which equals to M multiplied by V divided by R squared. So with that said, we could do 100 multiplied by, oh wait, R divided by M square root equals V. Anyways, that equals square root of 100 multiplied by 1.5 divided by what is the mass 2. Whatever that equals in your calculator should be correct, which gets you something like 8.66 meters per second. Next thing you have to do is plug it into MV, because it's circle, the cross product turns to multiplication. So, what was it called? RMV, which is why I think it's called cross multiplication, because if it's 90 degrees, you get that, but I don't really know. But R is 1.5 multiplied by 2 multiplied by 8.66. 8.66 multiplied by 2 multiplied by 1.5 equals 25.9, which is B. It's supposed to be a point 9. And if you were questioning in your handbook, there is angular momentum over here that allows you to just cheese it. Because, I mean, you're not going to remember every single equation from your college. So I only know that because orbital dynamics requires the knowledge of that very often. Okay, a disk rolling along a flat surface at a constant speed of 10 meters per second. Its diameter is 0.5. At a particular instant p, on the edge of the disk is 45 from the horizontal. What is the angular velocity of for the p? Okay, so over here, you're first going to do this, which is going to give you the omega over here. So it's 10 multiplied, because that's the pivot point and the rotational axis point. So omega 10 multiplied by r, which is 10 multiplied by 0.25, is equivalent to omega, which if you grab your calculator, it is 10 multiplied by 0.25 equals about 2.5 omega. And now with that, we need this angle, which we need the sine rule or the cosine rule, because we have 1.5, 1.5, we have this angle that's 45 plus 90. Um, we don't have this angle over here. So we need law of cosine or law of sine. I'm assuming they should give me it over here somewhere. Don't tell me I have to go all the way to the math section to figure that out. Like they must have it on ready for us. You're joking. Maybe go and memorize the law of cosine or law of sine, because I hate going back and forth on this huge document with all the things you ever learned. You're serious right now. Oh, you're joking me. Okay, fair enough. If that's how you're gonna play it, we go all the way to the front and go to mathematics again. We go all the way to law of cosine. Euler's idea trig, law of cosine here, and then you just apply one of them. And since we know the angle of this, we know the angle here, we know the side lengths of these two. We can play a square equal b square plus c square minus bc cosine a. Maybe before the test, like memorize that thing, because if they're not, I don't understand how the logic goes on this stuff, but they should really just give you that, honestly speaking, in the dynamic section, in my opinion, but they don't. So, and the static section, they should really put it in the static section too, because a lot of geometry is used. But then again, most questions don't need that. I think this is just an odd one out that needs it. Okay, so obviously we have oh, this is 0.25, 0.25. 0.25 square plus 0.25 square plus I don't know what, I mean we're looking for a, right? Oh wait, so let me just 0.25 square equal a, which is this length, plus 0.25 square minus 2 0.25 square, 0.25 square, and then cosine, not square, but cosine. And then A is 90 plus 135, basically. And if I get that into my calculator, is there like a way, is there like math, and then there's log cosine and sine in here? I don't think so. So you have to do it manually. That's fine. Minus 2 multiplied by 0.25 multiplied by 0.25 cosine 135 equals. Okay, I get a length that is too tiny for even me to think that's right. Um, Maybe I did something wrong, or it's not in radians or something like that. No, I think I just messed up somewhere. Oh, I think I multiplied something by 2 by accident. Let me just do everything again. 0.25 square plus 0.25 square plus 2, minus. Oh, I think I accidentally butterfingered um the multiplication symbol when I'm not or something like that. Here's the thing with my calculator, you have to like really type it slowly or like meaningfully press it or skip something. I did press it, it just skips it. And that happens with a lot of calculators. So when you're doing a calculator, go a little slow sometimes. So that's L equals 0.21338. So what we can do here is do the omega on this because this is a IC point basically. This is the movement area where it moves from. So we can do what we call I forgot what it's called actually. 0.2 1 is equal to R, and we can multiply by omega to equal V. So what you just have to do is basically do where's omega? Where's omega? Seriously, 2.5. 2.5 multiplied by this, so 2.5 multiplied by 0.21338. So just do multiply by 2.5, and you get about 0. That's wrong. Um, did I get omega wrong? Uh, maybe I did. Maybe I did. Is omega R equal VO, right? And omega equal VO divided by R. Oh shit, you're right. I got that one wrong. So it's 10 divided by whatever R is, which is 0.25. My apologies on that one. It's 40. 40 multiplied by that. This is wrong. 40. My apologies on that. 40 multiplied by 0.21 equals about 8 point. That's also quite wrong. So let me just redo this again. Put a 13th time. Multiplied. Oh, I think I did not write the I don't think I got the log cosine working correctly. Let me do the log cosine again. Plus 0.125 square minus 2 multiplied by 0.25 square multiplied by cosine 135. Maybe I wrote, let's, hmm, um, is it in degrees? Yes. Oh, I forgot to square root it. Duh. My apologies. Yeah, it's 0.4. Yeah, this is wrong. There's a square on top here, so to square root this equal 0.46, 0.46 multiplied by 0.46. There you go. Multiplied by 40. Okay, that's 18.4, which is this, which is a D. And that's going to be a little embarrassing, but we got it through eventually. A car which travels around an unbanked 50-meter curve without skids. So the coefficient of friction is 0.3. What's the maximum car output? So we can do this equal max, which is basically equal to saying negative, once again, mv squared divided by r. Yes, and then that equals to, what is it? Normal force, right? So it's going to be mu normal because that's the only thing that's keeping this thing alive. The negative direction, going the same direction as that. So mv, so it's going to be v equal, delete the m, and it's going to be r over m mu n. Wherever n is, um, I don't think there is an m here, although there's no mass. I'm assuming that means that v equal r over m mu mg basically because no bank. So these cancel out. V equal r mu g. And then, oh wait, there's a square here too. Square root, and we get v equal that. Let me just grab my calculator out. There's square root on this side too. So it's r, which is 50. And then the square root of 50 multiplied by 0.3 multiplied by 9.8, which equals 12, which is completely off base. Something is wrong. I got 12. Okay, I got 12.13. This is v. Okay. I guess this is not the max force possible, although, or something like that. Um, right. Why is that? It is meters per second. Oh, the answer is in kilometers per hour. Why would you do this to me? Why would you do this to me? Seriously, why would a question do this to me? All right, meters, So 1,000 meters equals that. So it was 1 over 1,000. And then, oh, it's 3,600 on top. So it's like that multiplied by division, 3,600 divided by 1,000. I meant what that, clear. Multiplied division, 3,600 multiplied by 1,000 is 43.64, which is 44. So this is, I guess there's a lot of questions trying to test your significant digit notation. Like these are all significant digits. Anyway, traveling at 100 miles, kilometers per hour around the bank height of curve, okay, 1,000, with a bank angle, is it necessary that the friction will not be required to resist the centrifugal force? Now, here's the thing. Um, there's a little trick to this, honestly. There's a formula which is tan angle equal VT squared GR to figure this out. But this formula isn't given here, and you kind of have I don't remember the derivation of it, but you can search on YouTube, I guess. Um, but yeah. But I think we could try to derive it a little bit. If you don't get anywhere, well, I tried. But in reality, you can just memorize that equation and be done with it. Sine theta and cosine theta is what I'm predicting the secret is into this thing. So traffic light was traveling around a bank highway curve with a radius of 1,000. So it's like this, right? And then you need to get the angle of here. What is the bank angle is necessary that the friction will not be required to resist the centrifugal motion, which means that is the friction is this way. And you're basically trying to figure out this formula, right? Summation of that. Maybe my headcanon is probably something like this. You get something in x divided by something in y, summation like this, summation y, and derive it all the way through. Now that is baloney. This is a formula that doesn't seem to be on the equation sheet. I've been trying to find that last time with a certain equation over here. There's another question somewhere. I forgot. Is it this one? I don't remember. But there was another one with friction. I could not find that form over here. Please do tell me if there is. But I think just memorize this one formula. Like this is not hard to memorize. I mean, it's VT, which is tangent velocity squared divided by GR. I don't think you will spend much time. And actually, I'm not going to waste my time trying to derive it because that's literally how you're supposed to solve it. Uh, there was another question, and I did do it by hand and did the division and did do all of that stuff, and it's not worth it. Just I mean, it's not that hard. Basically, what happens with the summation is that you do, I believe, weight, and then you do the minus force, but the newtons actually cancels out, so you get like a cosine sine thing, and a sine cosine diagram like this, and there's a minus and a plus, and then you can and it solves it. But if you simplify more from that state, you get the tan angle. And that is a beautiful way to say, hey, just memorize it. It's not worth it. So just do that. And more thinking about it, don't try to memorize it. I don't try. I mean, you can drive it on your own time, but for a test, you're wasting your time. Just memorize this equation, and you should be good. So instead, do 10 negative 1, 1,000, 100, sorry, by 1,000 divided by 3,600 divided by 9.8 multiplied by 1,000 multiplied by 3,600. Parentheses 9.8 multiplied by 1,000, which is 0. That is wrong. 9.8 arctan. One. Oh, there's something I didn't do. It's v squared. I forgot the square. Just put the square on top, and we should be good. Oh, it's not gonna let me do that. Huh? You're gonna make me redo the whole entire equation. Great. 100. Maybe this will work. Oh, I get 4.5, which is C. All right. Anyways, let's do the next one. Which a center of gravity roller coaster car is 0.5 above a rail. The rail is 1 meters apart, basically saying something like 1 meters apart, 1 meter. Um, what is the maximum speed that the car can travel around the bank? Curve of radius is 15. Without the inner wheel losing contact to the top wheel. Okay. This feels like it is well, first of all, there's a force this way, which is going to be FC, and it's going to be in the X, CG, which I'm assuming is going to be in the middle, center of gravity 0.5, because it is 0.5 like this. The rail is 0.1 parts apart, and that is over here to say. Of the cart. What's the maximum speed the car can go? So this is summation. I think you can just do a summation over here because if the moment is disturbed, and if the moment is stable as zero, it won't flip. But if the moment is disturbed enough, it will flip. So moment over here of, I don't know where should start. Let's just choose over here, moment equals zero. Well, then it's W multiplied by X, which will get a positive, minus FC multiplied by Y. All right, so that is saying equal to zero, and then this will give me everything. I guess it's actually, when we're talking about it, I did it kind of wrong, where, no, it doesn't matter. Because I think it's supposed to be equal to being like AC like this, maybe F equal MA equals like this, and then so on and so forth, which is interesting. I should probably look into that. Anyways, weight mg x equal fcy. I'm trying to figure out what. Again, the speed without losing contact. So this is important, this one. So mg xcg over ycg, and then we're going to do mv squared divided by r. So we're going to do r, delete, divide by m. So it's going to be rg xcg divided by ycg square root equal v. Anyways, so on and so forth. We do second square root. We do r. What's r? R is 15 multiplied by 9.8. And then multiply by 0.5, and then divide by 0.5, looks like. Which makes you question why you're doing that. It's 12.12, so it's B. That was an interesting question. Don't like it. Um, it's an interesting question because if there's a moment you triple over. I don't think this was a good question in my opinion. Decided to, yeah, just gonna say it. Um, yeah, because I don't think, yeah, yeah, I don't think so. But not my decision. All right, next one. A cylinder with a height of 3 has and a radius of 0. Oh, I do it like the opposite way. Radius of 0.3, 80 kilogram. The cylinder sitting in the S-axis oriented to the major axis, parallel to the y-axis. So I'm assuming it means this. Major axis, probably the big one. What is the moment of inertia? Oh, yeah. This is just copy and paste. And you ask oriented to the x-axis. Okay, so you go down over here to a cylinder over here. You're just doing this one, I believe. Okay, pretty sure. And it asks for what is the mass inertia in the x-axis. So it's orientated. So it sits on the it says to y. Oh, so it's actually like this along the x-axis. So x-axis is this sitting in there. So it's gonna be a moment like this. Just need to double check. So that would mean that it would be ix equal m 3r squared plus 4h squared. No, it would be 4, yeah. Divided by 12. Because this, I'm assuming it's sitting on it. So it's like that. That's the x-axis over there. So with that being said, you just plug and chug at this point. Okay. The mass of this is 80 kilograms, and it's gonna be parentheses 3 multiplied by whatever the radius is. Radius is 0.3. Uh, cubic or square? Square plus 4, whatever h is. The height of it is 3, so it's gonna be multiplied by 3 square divided by 12, which is parentheses over there. What? Let me double check everything again. I got something insane. So let's see, divide by 12, right? 3 multiplied by let me check the original question because I get something like 242. Let me just find the original question. What is this? Where is this question? I knew it. This question is wrong. Over here, this is supposed to be Philip White. Because I don't think I can't find a mistake, and it's usually the computer's mistake that actually when this happens, it's actually 50 apparently. I don't know how it got transcribed that wrong, but with that change, and apparently this is supposed to be also 150 in the bottom, apparently. So this is wrong too. Where is it? This one. Apparently it was supposed to be 150. So we can do another like this, erase that. You go, I mean, and then do it this way. Okay. And this one's supposed to be, oh, no, not the text. Order to the fund, please. Okay, and then now fit it. Okay. That changes something in the m. When we did m parentheses r squared plus 4 h cubed 3 divided by 12. This thing changed now. Because I got like 250 and I was like, well, I didn't make a mistake in plugging in. So I was like, what's going on? So it's 151. So yes, that is check. Yeah. Okay, next question. So a uniform thin disk has a radius of 0.3 meters and a mass of 2 kilograms. A constant force of 10 newtons is applied tangentially at a revolving but unknown distance from the center of the disk. The disk accelerates at its axis about 3t radians per second. This is alpha. What is the distance from the center of the disk at which the force is applied at 12 seconds? Here's the thing. There was an error over here that made me redo this like 16 times already. So let's begin. So first we start with 3t, which we can do t equal 12, which makes this 36 equal alpha radians per second at this point. And you're next asking, what is the formula we're going to use? The formula we're going to use is this moment idea, because there's two ways to define moment, which is I alpha. The other one is force times this, force times r, right? That's another way to describe it. So r equal I alpha divided by f is the way we're going to define it. I equals 1/2 mr squared for a thin disk. So 1/2 multiplied by 2 by, what is this, 0.3 square. And you're going to plug into here with the 36, with the 10, and you should get the answer you're desired looking for. So it is, I get 0.324, and that is multiplied by 100, which is 32.4. So that's A. Next, a torsion pendulum consists of 5 kilograms. Okay. Disc with a torsion pendulum is like this. Diameter of 50. Okay. 50 cm. Attached at the center of the rod is 1.5 length. The torsion spring constant is K equals 0.625. Describe the mass of the rod. What is the natural frequency of the torsion? I believe it's, I don't remember. I actually genuinely don't remember. And I know it's gonna be over here. Don't worry, your charms are here. It is definitely gonna be here. Um, oh, they even give you this. I didn't know that. Here, torsion. So it is basically square root of K over I. I should have actually known that. It's omega n. Okay. That's actually kind of embarrassing because I should have known that. Either way, we're gonna stop it now. Um, the first thing we're gonna do is R equal R equal, what is it? 50 centimeters divided by 2, which is 25, which is the m. So 0.25 is what we have. Again, it's 1/2 mr squared for this one because this is a cylinder, which is same as a disk. In theory, it is because if you look at the derivation, you'll see why the z is a unit place basically, so it doesn't matter. Anyway, with this, what's the mass of this? 5 multiplied by r squared, which is 0.25 squared, equals about 0.156. Okay, equals square root of what k is. K is what? K is 0.625 divided by 0.156. Okay, that is gonna be 0.625 divided by 0.156525, which that doesn't sound right. I get an insanely big number, which I don't think is correct. Because I forgot the square root of 2. All right, now I got 2. The reason I got 4, I was like, what's going on? But I realized I divided inside, but I forgot to do the square root of 2. So that was what the was. Next one over here is a 3 kilogram disc. Okay. Oh, this is going to be a little bit interesting. A 3 kilogram disc with a diameter of 0.6, okay, is visually attached to a point B to a 1 kilogram rod. Oh, that thing actually matters now because it has a kilogram. 1 meter in length. The rod disc combination rotates around the point A. Okay. The angle ABC is a right, what? Okay, AB, that, oh, this is going to be a geometric question. God damn it. You're making me do this, huh? Okay. What is the mo just a moment of inertia? Oh, thank God. Oh, thank God. It's not asking for something ridiculous. So, yeah. Um, so we could just get the moment of inertia and do this, right? There's nothing special about it. Um, get this over here. That's gonna be on the edge, so it's gonna be ml squared divided by 3. And the cylinder is gonna probably be the same, 1/2 mr squared. We're gonna actually need to know the displacement because we're gonna use a parallel action theorem on the probably the disk. What's going to happen is basically we're going to make this our way of judging. So this is moving. So basically this is our AD. This is our displacement. And then we're going to be mass multiply displacement square, right? That's how we do it. So it's going to be this plus 1/2 mr square. And then it's going to be plus this whole entire direction, which is 1 square plus, I don't know what this the 0.3 square root equal that. And that's going to be over here. with d that's the d square part with the mass of the second, and this is 1. So that's how you do it. I think that's it. So let's just explain what we did. 1 kilogram multiply 1 uh to the cube part of 3. So that is weirdly 1 divided by 3. Yes. And then 1 divided by 2 by the mass is 3 multiplied by 0.3. Okay, I'm gonna get a calculator, but it looks like it's near 0.6 divided by 2, which is 0.3 looks like. No, 0.9 actually. 9 divided. Okay, so let's grab your calculator. Um, definitely means 3 divided by 2 equals 0.45. That's about right because 9, 0.9, and then divided by 2 is 9.45. Anyways, 0.45 is yeah, I think that is what I got, right? Oh no, I forgot the square. Shit, sorry. This is actually 0.135. That's what I get. Anyways, it's gonna be plus the mass, which is 3, and it's gonna be multiplied by the square root of 1 square plus 0.3 square equal no, I need to square root it, square that. And it's about 3 point, yeah, it's about 3.3. All right, and that's about it. It's about 3.27, and you add that to here and add that to here. So you get 3.327 multiplied by 0.135, and a plus, sorry, plus 0.125 plus 1 divided by 3 equals 3.73. Okay, it's D. You just have to add all those up. You get D. Next one. All right. This is what we call a product of inertia solve. So it's X, Y, dA is what we're trying to solve for. And let me tell you this, basically over here, there's no X because it's in the X axis. So basically this is gonna be 0. And here's how you know it, how you know it. In the matrix over here, there's something called I, X, X, I, Y, Y, I, Z, Z. The off diagonals are when you do I, X, Y, I, X, Z, and so forth. Guess what? They only show up if it's not symmetric. Once it is symmetric, it does not show up. So if you want to make it show up, all you have to do is basically make this make the moment calculation non-symmetric. But for now, we have a symmetry over here, so we're done. We're basically done. If it's, that's basically A. So basically what's happening is a symmetric analysis. And we kind of did that analysis in my capstone, where we look at this and that is a symmetric, right? If I was to do something like double, well, it was not so symmetric, but it still is because of the axis symmetry, because if you do the times, same idea of this one. So yeah, we go over here, a wheel with a radius of 0.75 starts from rest and surveys clockwise. The angular acceleration in the wheel is defined by 6t minus 4. What is the resultant linear acceleration of a point at the wheel equals 2? So we know it's 6t minus 4. Let me make sure that in the actual original equation, it was 6t minus 4. It was, okay. So we plug in 2, right? So 12 minus 4. What does that equal? That equals 8. And that's rads per second square. We also know that if we times it by a distance over here, so alpha times r is equal to a in certain situations, is what I was told. Yeah. But I'm trying to think, is that what they're looking for? What is the resultant linear acceleration? Um, this only gives you the tangential force, although. So this gives you tangential. This does not, however, give you the actual n. So you're gonna have to get the n yourself. Okay? So if I were to give you this, it would give me my calculator. Uh, a wheel with a radius of 0.45 starts from west and accelerates clockwise, goes this way. The angular acceleration in radians of the wheel is defined by alpha equals 6t minus 4. Okay, no longer constant. What is the resultant linear acceleration of the point of the wheel at equal 2? So here's the thing. Now, when we talk about this, there's actually two types of forces. One centrifugal and one tangential. This is called AT, and this is called N. And this is a confusion that people get because you're no longer working with uniform A or any of the other formats. So first thing you have to do, this equals 12 minus 4 equal, by that I mean like 0 angular velocity or something like that. Anyways, With that said, is 12 minus 4, which is 8. Okay? And this is radians per second. And this will be used square. This will definitely be used. This is just telling you that there's 8 radians per second here. It really is just the angular rate. Nothing more, nothing less. If I were to multiply by this by r, this will give me AT. So 8 multiplied by 0.75 equals, with my calculator, 6. Next, AN is the centrifugal force. So we all know what the centrifugal force is. It is, oh God, it is R omega square, right, in the minus direction, but it doesn't really matter in this case. We can write minus if we want. And then this is going to be derivative of integral of this. So if I were to integrate this and get a number, we get omega O, and it states that what? It starts at rest. So we're good. Okay, so we do 6 divided by 2, t squared minus 4t plus c, but c equal at 0. So this is 0, so c equals 0. So 6, so 3 t squared minus 4t is what we find. And we multiply that by 2. So 3 multiplied by 2 squared minus 4 multiplied by 2 equals 4. And this equals 4 squared multiplied by r, which is 0.75, is about 12. And then we do 6 squared plus 12 squared. So second square root of 6 squared plus 12 squared equals 13.4, which is C. Which is C. And then we clear this. We go to the next one, which is a uniform rod AB of length L and weight W is pinned at point C and restrained at OA. The cable is suddenly cut. Okay. Cut. The rod starts to rotate, clearly. Yeah. About point C. That makes sense. And point A moves down. Yes, that's right. And point B moves up. Yeah, that makes sense. What's the instantaneous linear acceleration of point B? Okay, that is fair. Um, well, I need to know the no way. Do they tell me the mass at all? Or let me just check if they have a mass in the original question. No, okay, so this doesn't have any mass. So this is gonna treat it as like a rod, I'm assuming. Um, what a weird question. Let me double check again. There's no M anywhere, so I'm a little weirded out. Okay, I guess there's no M, so I guess it just got canceled out somewhere. So first thing we're gonna do is this is a pivot point. So we're gonna treat this as where we get our I. So there's two I's over here, I over here, and I over here. But in reality, we can treat this as one rod and we can just displace it by how many we do. So what that means is we can go over here, look at our section. Well, we could treat it as kind of like a rod over here. I think it's gonna be ML squared divided by 12 then. With that said, we can treat it L divided by 12, right? And hmm, I wonder, did my camera block it? Let me just check something real quick. Sorry. I want to make sure that my camera didn't block what I wrote earlier. Let's just be a quick second. Oh, it did. Oh, so what I did was this over here, which equaled my apologies. Over here, it equaled what did it equal again? 13.8 or something. If I square root of both of them, my apologies for not showing that. Okay, now we can do this one, which is ML squared divided by 12, and then the plus this distance over here, which is L divided by 4 by mass. And it's going to be squared this way. With that said, you can get a simplified form with this, I guess. Really not, we have to get the moment first, basically. So in this sense, the whole entire moment is probably just going to be in here, weight. So as you know, summation MC is basically F times R. So F is basically going to be weight times whatever is L divided by 2. Yeah, there we go. And this is going to be equal to mgl divided by 2. And I already can see where we're going to go with this because it asks for linear acceleration. Over here, it's going to be I alpha equal fr. So we can put fr here. So mgl divided by 2 divided by I equal alpha. So in this case, we say, whew, let's take a long time. So let's do this. mgl divided by 2, parentheses, Let's simplify this a little bit because I'm pretty sure these are the same units. So m L squared divided by 12 plus 16 L squared m. So let me just use my calculator. 1 divided by 12 plus 1 divided by 16 equals, oh, that's interesting. I get 7 divided by 8, 4, and we get L squared m. 7 L squared m divided by 48 equals, this is lowercase m. So with that said, wait, mass gets deleted here too. Yes, that makes sense. So mass gets deleted here too. One of the L gets deleted, so there's a mistake somewhere. Ah, here. Uh, MGL, no. I guess L doesn't get deleted. Oh, as for linear. So I guess I'm gonna multiply it out or something. I don't know yet. We'll figure that out. So 24 over 7. Am I getting that correct? 24 over 7. No, this is 4. 4. This is 4. It's 24, so it's 12 over 7. 7L. And then I have to do AT because it's instant linear acceleration. That's a tangent force. So it's going to be 12g over 7L multiplied by L divided by 2. No, 4, 4, 4. Keep on doing that mistake. This is 4. So this is deleted. This is deleted. So it's 3 over 7g. So C. Okay, we get C. So next one's next. Oh, we're using the same equation. Okay, I think this thing was actually probably used on this thing too. It just didn't I guess they didn't generate it correctly on one of them. What I mean by that is that they probably had the same question, but different textbook use a different way, I guess. Um, yeah. Anyway, 14 is asking about what is the instantaneous reaction at point C at the moment of rotation begins. 12g over 7L. That's what we have. I hope there's no question like this. This is like kind of a little bit what's the right word? Off yeah. So we need to figure out the G. So I think we need IC, which is basically 1 divided by 12 ml square. And then we need to use the summation of moment at reaction IC. So summation of MC equals R and L divided by 4 equals IC. And then there's alpha C. Alpha C is universal. So this is over here, as you know, is universal. So R, yeah, C. Sorry, that's the RC. That's the reaction force. And then we equal to uh 1 divided by 12 ml square. Yep. L square. Alpha is 12 g over 7L. And then there is 4 divided by L, so this gets deleted. 4 m. So that's 4 omega. 12 with derivative of 12. So C. I got C. Okay, next one. Okay, this is 150 1,530 kilocar that tolls a 30 kilogram. The coefficient of friction is between the tire and the road is 0.8. How fast can the car travel without an up around an up unbanked curve of radius 6? Didn't we just do this one? I feel like this is the same question. Oh, without the ski. No, we did this question. This is 4C equal FFR, which is basically saying mv squared divided by r equal mu n, and n is basically, oh, I guess that means that we'll get this question often on the exam. Uh, I guess. R. So we need v equal mu n. Oh, this I thought the 9.8. Mu n r divided by m square root. Yeah. So equal vt. I hope I'm right. I think I am. Because this is mu. Yeah, I'm pretty sure I'm right. I'm just a little suspicious because we did this so many times. Let me get my calculator and do it. So 0.81530, 9.8 parentheses by whatever the length is, which is 2,000, divided by whatever the mass is, 130, second, square root, division, 0.8 multiplied by 1,530, multiplied by 9.8, multiplied by 200, divided by 1,530, which is none of the answers. I get 39.59 meters per second, but I already saw that. So I will just do the 3600 divided by 1000 equal 142. So it's actually D. That's like the 16th time I saw that same way of doing it. Anyway, the what isn't this the same tangent? Yeah, this is a tangent. Okay, so what is a plane curve? I guess that means in the test, this equation gets tested a lot. So remember this equation because this is not the first time we've seen it, and I feel like I've seen it like 16 times at this point. Um, and 100, and this is gonna be multiplied by 3, 6,000. No. 1,000 divided by 3,600. That is VT. Okay, so let me grab my calculator out here. 100 multiplied by parentheses 1,000 and then 3,600. And then we put that number to 27 squared divided by 9.8 parentheses what is R? R is 200. And then you just do that. 10 division 27 square 9.8 multiplied by 200 equals about 20 degrees. 20, well, I think it's just gonna be B because I'm pretty sure it's just a rounding error at this point. But I get 20.4, which I don't know how they round. They probably rounded up and just left me, you know what I mean. Okay, next one. A wheel with radius 0.75, all right, has a mass of 200. The wheel is pinned at the center and the radius of gyration is 0.25. A rope is wrapped around the wheel and supports a hanging 100-kilogram block. What is the wheel? When the wheel is released, the rope remains unwind. What is the angular acceleration of the wheel? Okay, so the wheel is probably hollow, first of all. And we're going to do something called, first of all, it's IMR squared then. Radius of gyration. All right. I haven't seen that word in quite a bit. What's the radius of gyration? 0.25. Okay. All right. We'll figure it out. So first thing to mention is the radius of gyration. Radius of gyration is basically if you have certain mass and do an integral on it and get to the I form and you reverse engineer it to make it equal like mr squared instead, and that's the radius of gyration, making everything easier for you guys to actually do. I now remember it. So I equal mk squared, and then that means this is 200 multiplied by 0.7 no 25 square, which equals 0.25 square equals 12. What? Okay, that's a huge number. Okay. All right, that equals 12.5, but I guess it's right. Now, next thing is let the block accelerate downwards by A. So it's like this, right? This is 100 kilogram. I'm assuming you already tried. If you want me to read it, a wheel with 0.75 meters radius has a mass of 200 kilogram. The wheel is pinned at its center and has a radius of a gyration of 0.25. A rope is wrapped around the wheel and supports a hanging 100-kilogram block. When the wheel is released, the rope is begin to unwind. There, what is the angular acceleration of the wheel? So there's an A over here. A equals R over multiplied alpha. So A, if you ever have a doubt, is 75 alpha. Or in other ways to say it is alpha equal A divided by 0.75. Next, we do a little bit of statistics, a little bit of analysis over here. There's a tension over here, and there's a mg over here. So T minus, no, we could do, well, it doesn't really matter. So we could do T equal positive, and then the minus mg equal ma. This over here is 100 multiplied by 9.8. And then this is going to be T minus that equals 100A, basically. And with that said, we could do TR equal I alpha too. And with that said, that's because of the wheel. And with that said, we can say T multiplied by, but remember, because of how it works right now, I did T like this, a T like this is happening, so this is negative. So 0.75 equal I, which is 12.5, 12.5. And alpha is basically A divided by 0.75. Now, with that said, we have a ratio to denote T with A if we ever need to. So we actually can get A from this. So let me get my calculator out. Division 12.5 divided by 0.75 equals about am I forgetting something? 0.16.66 A. And then we can do T equal negative 16 divided by 0.75. So divided by 0.75 equal 2222 or 22 newtons. No, I forgot the A. Sorry, there's an A over here. 22A multiplied by A. What that does is go over here and we can do 22A minus 100 9.8 equal 100A, right? With that said, you can do 100 minus 22 equals 78A. equal minus 100 multiplied by 9.8. So this is just 100 divided by 9.8. And then this, wait, not divide. Why am I doing divide right now? And then divided by 78 equals about 12 point. Did I do something? That sounds totally wrong. Okay, 180. And then we have other side. This. Oh, I see what's going to happen. So this is minus, so this is minus, so this is actually plus. So what this should be is 122 negative. So it is 100, 122. So that is A equal 8.03. And then A equal 8.03 divided by 0.75 equals about 11. So C. And I'll do what C here. This is my second time doing this.